Good afternoon, students. In the last class, we have solved a problem based on LMTD method. So, in continuation to that, we will solve one more problem today. Okay, the problem. So, here it is. This is the problem here. Here, he has given a heat exchanger and it is used to heat water. Heat water at a flow rate of something is given. So, m dot h or m dot instead of h, you can put w also. That is for water you are saying. So for water, this value is given as 20 kg per second and 25 degrees centigrade to 75 degrees centigrade. The values are given. And then he is using gases on the other side available at 300 degrees centigrade and 180 degrees centigrade, and u value is given to you. The u value is given as 95 watt per meter square Kelvin, and Cp value for gas it is given as 1005 joule per kg Kelvin. It is also given, and he's asking you to find the area, determine the area required. Determine the area required for the following cases. He is asking. See, parallel flow, you can do the problem. Counter flow, you can do the problem. Okay, these two things are already completed in the last class. Now, I'll be dealing with this one. Okay, I'll tell you how to solve if it is a cross flow heat exchanger when both fluids are unmixed. This case, let me take and solve it. Okay, so if you look at these temperatures here, which one is hot and which one is cold? This is hot, this is cold, because the temperatures you can see 300, 180 is hot, and these temperatures 75 or less than this, so these will be cold. So as per the nomenclature, you have these things as capital T's. Hot one is capital T, small one is for cold. Okay, that's what the nomenclature we have in data book. So based on the case, your T1 and T2 will vary. Okay, you have to take care of that. Based on the case, you have to take the T's appropriately here. Okay, see, available at 300 degrees centigrade means they will enter at 300 degrees centigrade. So this is T1 and they will leave at T2. So since this is a cold fluid, it has to get heated up. So it will enter with 25 and leave with 75. So appropriately T1, T2 you will take. Oh, that is clear to you now. What is T1, T2, T1? Small T1, T2, capital T1, T2 is very clear. Okay. So cross flow, both fluids unmixed case. So where is it? How to solve it? Okay. For that, you will have to use your data book. Okay. In your data book, you have yeah, here it is. You can see he has given the parallel flow case, counter flow case, and then multi-pass case, and also the cross flow case. For this, the formula is Q is equal to FUA into LMTD. Okay, let me write this formula here. So, what is this page number? Page number is 160. Go to page number 160 in data book. Take this formula here. The formula is Q is equal to FUA into LMTD. Okay. According to him, LMTD is this way. I am writing LMTD this way so that you can easily identify. Okay. So in this, you have U. Okay. U is given in question. Okay. What is the U value given in question? It is 95 watt per meter square Kelvin is given. Okay. Area, how about area? Area is the thing that you have to find in the question. It is unknown. Okay. Then how about LMTD? How to find LMTD in case of a cross flow? We have to look into. Okay. You see, whenever cross flow is given, you will use LMTD for counter one only. Is that clear? Whenever LMTD is taken for a cross flow kind of a thing, you will take the LMTD for counter one only. But the only difference is here you will get something called as F. Here you can see there is something called as F. This F will be taking care of your cross flow. Okay. So what you have to do, LMTD as usual you have to calculate like a counter flow only, but F you have to take while taking the Q value. So that will account for the cross flow. Okay. So to do that, first thing to do is find LMTD in case of a counter flow. For counter flow, what is the formula for LMTD? See, I told you the formula for LMTD in the last class. The same thing is given here. Okay, the counter flow. If you forgot also, you can look at this and write it. Okay, let me write it from this one. For now, this one also you will get the practice. If you forget now, you can use this. This is capital T1 minus small t2 minus capital T2 minus small t1 by ln capital T1 minus small t2 by capital T2 minus small t1. Okay. So this is the LMTD. So tell me what is the value of T1 here? It is 300. T2 small t2 is 75. Capital T2 180. Small t1 is 25. It is given in problem. You can carefully observe. ln the numerator by denominator. The numerator is this value, left side value. The denominator is right side value. That is 300 minus 75 by 180 minus 25. That is your LMTD. Tell me what is the value of this LMTD.
187.83
187.83
degrees
degrees
Celsius.
centigrade. You are done with LMTD. Okay. So next thing to do is here you have to find what is this F. Okay. What is this F? For finding this F in the data book, he has given something. See here you can read. F is the correction factor depending on RP and the type of heat exchanger. Okay, for FRP definitions, refer to the charts on 167 to 170. So let's move to these page numbers, that is 167 to 170. So if you keep moving down till 167, see here you can find P, R, and F. P, R, and F are there in this particular case. So this is what this is actually a. Let me look at this. Yeah, here you can see it is a one shell pass, two, four, or multiple tube passes. Okay, if you look at the question, in question, one shell pass, multiple tube pass. This is what page number 167. You have to refer for this solving this one. Okay, so here it is 167. The second one we take, it is a two shell pass and 4, 8 and any multiple type of cube passes. So for this, p value, r value and f value. Okay, so this will be in page number 168. So this is actually the second part of the fourth part actually, page number 168. Okay, so the cross flow thing we are doing here. Let us see where it is in our data book. So here you can see this is a cross flow heat exchanger with one fluid mixed, the other fluid unmixed. Okay, so this is a cross flow heat exchanger with one fluid mixed and other fluid unmixed. So it is in page number 169. That is this one. This one is page 169. Okay. Yeah, here it is.
Sir, I think it is 170, no, sir.
Yeah, it is 170. Both fluids unmixed.
Mixed, yeah,
Means 170. The other one is 169.
9.
Okay, anyways, you will have P, R, and F value. Anyways, right, you are right. So both fluids are mixed means this is not 167, this is 170. Correct. This is 169. Okay. So I will be solving it for page number 170 now. You do it for the remaining cases by yourself. It is similar way only. So let's go to page number case 5. I'm solving. What is this case 5? This is a cross flow with both fluids unmixed. Both fluids unmixed. Case we are solving. So it is in page number 170. 170 or one, oh yeah, it
Yes,
is
sir,
170.
170. 170.
Thank you for coming here. So this is a page number 170 here. Now what we have to do is, first thing to do is find the x-axis value, that is p. Okay, let's take this p here. The p is equal to small t2 minus small t1 by capital T1 minus small t1. I am simply writing whatever the formula that is there on the x-axis here. Here we have a formula. That formula I have taken here. So substitute and tell me what is the small t2 value, what it is. 75. Capital small t1 is 25. Capital T1 is 300. And the small t1 is 25 again. Tell me what is the value of this p.
0.18.
1818.
18. Yes, sir.
That is the p value. Next thing to do is find out the q value. So it's not q, it's r. It's r. R is equal to this one. This formula is there here. So what it is, tell me. Capital T1 minus cap 2 by T2 minus small t2 minus small t. This is equal to, the capital is 300 minus 180 by 75 minus 25. That is the R. Tell me what is this R value?
2.4.
2.4. Right. So let me move to the graph itself now. Okay. If I move to this graph here, on x-axis I have one value. What is that value? Tell me. P value that we have got. 0.18
18.
we got. How about this one?
2.4 R.
2.4 4 we got. Okay, so if it is 0.18, where is that value? This is 0.2 here. So 18 will be somewhere over here. Agreed?
Yes, sir.
0.18 is somewhere over here. Like this, you have to draw a vertical line. Okay. I cannot somehow draw it because I don't have that opportunity to draw that here. Anyways, this is a vertical line for representing your 0.18. How about 2.4 here? R2 is over here, this curve, R3 is this curve. So if I draw R2.4 curve, this curve will be something like this. Do you agree? Okay,
Yes, sir.
this will be something like this. So here is a point that is meeting for your 0.18 and 2.4. Let me take that onto my y-axis. If I take it onto my y-axis, what is the f value here? F value is somewhere around 0.97. Is that okay for you? Is it clear? See, what you have to do
Yes,
is you have to go to page number 160, take p value on x-axis as 0.1818, and then you find the 2.4 R curve, and then this P 0.18 will meet this one here. The corresponding F value you get here. The F value is 0.97. Okay, that's what you got. So that implies the F value is equal to 0.97. Is that okay? You have any doubts till now? No doubts, huh?
no, sir.
Thank you. Thank you for that. So what is the Q formula here? Q is equal to F into U into A into LMTD. This is the Q formula. Now, in this Q formula, you have F value, you have U value, you have LMTD value. You are asked to find what is the area value. But how about getting the Q value here?
MCPDT.
Q is found out by using
MCP delta
MCPDT.
T.
Q is equal to M into Cp into delta T. Okay. Okay. Which one will you take? You will take the cold one or the hot one?
Water.
You take it for cold here because m dot is given only for the cold one in the question. If you look at the question, m dot is given only for the water. For other gas, other fluid, the m dot value is not given. So you take it for the cold one only, that is for water. So m cold, Cp cold, delta T cold. M cold is given as 20 kg per second in the question. Cp of the cold one, is it given in question?
4180.
It's not given in question. You have to remember this. That is the water Cp value. You have to by heart this, or you can refer to page number 30 also in your data book. There also you will get the Cp value. How about the delta T value here? 75 minus 25. So the cold values are given as 75 and 25 in the question. I have substituted them here. Okay, these things I have substituted. Tell me what is the Q value now. Quick.
4180 kilowatts.
4180 watt. Okay,
No, sir,
so
kilowatts. One more zero.
one more zero. Yeah, right. Correct. This is the Q value. Right. Now, if you look at your Q is equal to F into U into A into LMTD, we have everything now. You have Q, you have F, you have U, you have LMTD. Only unknown is A. Calculate A. A is equal to Q by F into U into LMTD. Q value is 418 4 zeros by the F value we have found it as 0.97 from the data book. The U value is given in question, it is 95. LMTD we have found out it is 187.83. These are the things we have found out. So tell me what is the area?
241.
2415 point.
No, sir. 241.5.
241.5.
Yes, correct. 241.5 meters square. That is the area now. Is that clear?
సార్ ఒకసారి ఎఫ్ ఎలా క్యాలిక్యులేట్ చేయాలి ఒకసారి మళ్ళీ చెప్తారా సార్?
F మనం ఏం చేద్దాం అంటే we will do it for the other case now. Okay, we have done it for fifth case. We will do it for the sixth case now. Okay, quickly we will do it for the sixth case. That is a cross flow with one fluid with one fluid mixed. See, the procedure is same for all the things. It's just a repetition. If you can follow for one thing, you will get for the other thing also. So where is this? This is in page number 169. Go to page number 169. Here it is. Here what we have is a cross flow with one fluid mixed, other one is unmixed. So this is the case. So here also you will have same P. P won't change there also, and here also P formula won't change. We got this as 0.18. 1818 actually. Yeah, we got this. And R value also, it won't change. R formula also, it won't change. The R value we got as 2.4 actually. Okay. So now what you need is, you need F. Basically your requirement is F. For that what you have to do, you have to locate this 0.18 here. So 0.18 if I have to locate, it will be below 0.2. Okay, it will be below 0.2, and this one is 0.15. This one is 0.2. So if I have to represent 0.18, it will be somewhere over here. ఇది అర్థమవుతుంది కదా మీకు? ఇంకా జూమ్ చేస్తాను చూడండి. So it will be 0.18 here. So what you get here is a line like this. This has to be very straight line. Okay, I cannot draw that straight line here. Somehow you draw it for yourself. Okay, so that is a straight line. This is actually 0.18 line. Now that you have represented 0.18 line, you should also represent this 2.4 curve here. For the 2.4 curve, you have 2 here, you have 3 here. So in between you will have 2.4 curve. So the 2.4 curve will be something like this. So if this is 2, if this is 3, this is 2.4. So these two are meeting at this point here. At this point both are meeting. So if I extend it here, the F value will be what? 0.95. Is that clear?
ఎస్ సార్.
Okay, so now you take this F is equal to 0.95 and solve the problem. Only difference is the F, everything else remains same. A is equal to Q by F into A into LMTD. That will be equal to 418 by F value is 0.95. Sorry, this is U. This is not A, this is U. U value is given as 95 in the question. Substitute that. LMTD is given as 187.83 in the question. So the area will be something. You calculate and tell me.
246.6.
244. Yes, sir. 46 point.
2.6 meters square. Okay. So similar way, can you solve for this one also? The third one and fourth one. Can you solve it for yourself? It is almost similar. Or simply I will tell you the F values and you can do the calculations. Let's go to page number 130. That is the third case. The third case is 1 cube pass and 1 shell pass and multiple cube pass. 1 shell pass and multiple cube pass. Multiple tube pass. For this, what you have to do, you have to refer page number 167. Okay, let's go to page number 167. This is our 167 page. So P and R again will be the same thing. This is 0.1818 and R value is equal to 2.4. We know this. So here I have to represent my 0.18 on my x-axis. For that, I'm taking a vertical line here. This is a 0.18 line. And also I need 2.4 curve. So for representing my 2.4, I have to draw a curve like this. Because this is 2, this is 3, this will be 2.4 and this point will be your point representing both condition, and if you extend it up to this, that is the y-axis, you will get the f value equal to 0.96. Okay, so use this f is equal to 0.96 and solve this problem. F is equal to 0.96. Similar way you do for the fourth case also. It is 2 shell pass. It is 2 shell pass and multiple tube pass. For this, you have to refer page number 168. So if you go to that, F is equal to something, you will get. So let us come here. So here you have this one as 0.1818 and the R as 2.4. So if you have to draw 0.18 here, here will be your 0.18. So draw a vertical line here. Okay, and then you have to represent the 2.4 here. For representing 2.4, you have to start somewhere over here and then come like this. This is 3, this is 2, this will be 2.4. So what you get here is the point. It is almost close to 1. So F we can take it as 0.99. So in this case, only difference is 0.99. You got it? Is that clear? How to use the graph is clear to you all or not? Tell me. If you have any doubts, you can ask. See, generally in a given question, he may give two or three. Six he will not give you. Don't worry. Most of the times he will give only one type of heat exchanger, but few times he may ask you two or three heat exchangers also. So do it accordingly. Is that clear? Somebody please speak up, man.
Yes, sir. Yes, sir.
Yeah, thank you. Right, let's move to the next question. What is my question? Mm, Right, here we have a problem. As you can see, this is a counter flow problem, single pass counter flow problem. So this is the first thing to find in this question. Counter flow heat exchanger, and engine oil is to be cooled, he has given, from 80 degrees centigrade to 50 degrees centigrade, and cooling water is available to you at 20 degrees centigrade. This is given to you. Water flows inside a tube with a ID. So DI is given in question as 2.5 centimeters. Next, M dot for W is also given. It is 0.08 kg per second. Also, he is giving you oil flow rate also. Very good. M dot oil is giving 0.16 kg per second. The heat transfer coefficient is giving H HW. That's right, HW. That is equal to what? 1,000 watt per meter square. Degree centigrade is given. Kelvin also the same thing only. It won't vary. HW is H oil is given as 80 watt per meter square Kelvin. And fouling factors F is equal to 0.000018. What is the unit given here? Meter square Kelvin per watt. Meter square degree centigrade per watt. Meter square degree centigrade per watt. This value is same for the water and oil. So, I need not write it again. The same value is given for water and oil also. And he's saying the resistance is negligible for tube wall. The resistance is negligible for tube wall also is given. So tube wall thing you can neglect, and he's asking you to calculate tube length. Ultimately, you need length. So how to solve this problem? Let us see. See, in this particular problem, he has given only three temperatures, these two and this one. The fourth one is not there. So can you solve this using the LMTD method? Tell me. Please speak out. See, generally, if in question you have to solve the problem by LMTD method, you have to have four temperatures. If there are four temperatures, then only you can go for the LMTD method. Here, you don't have four temperatures. Okay, but the fourth temperature can be found out using the data given here. Okay, how can you find the fourth temperature? Can anyone tell me? Looking at the data given.
MCP delta T
Q
equal
hot
to
equal to Q cold.
Very good. Q hot is equal to Q cold. You can use Q hot is nothing but M Cp delta T on hot side is equal to M Cp delta T on cold side. Very good. So using this, you can actually find what is the temperature on the unknown side. Okay. So if you look at these values, this is hot and this is cold. So the hot one will be T1. This one will be T2. Why this is T1 and why this is T2? Somebody speak out. Why is this 1? Why is this 2?
Entry exit.
How can you say that 80 is only entry? Why not 50 is entry?
Hot since oil needs to be cooled.
See, since this is hot, what will happen to this? Its temperature will decrease. So while it is entering, it should have high temperature. While it's leaving, it should have lower temperature. Based on that, you will decide actually. Right. So this will be small t anyways. Okay, whether it is big or small, you have to decide based on what to get on the other side. Right. So let us substitute these values and find out that h there. So what is the mh given in question? M on hot side, that is M of oil, it is 0.16. 0.16. Cp of oil, is it known to you? Is it given in question or not? Please speak out. Cp of the oil is not given in the question. So what you have to do?
Data book.
Cp of oil you have to get from the data book. You have to go to so and so page number. What is that page number? Tell me.
33.
Page number 33. Yeah? Let me check. In liquids, you have to check actually. 33. Here you can see in page number 33, there is engine oil formulas. Okay, engine oil values, the property values. What you need is Cp value here. Okay, here you have the Cp values. So which one will you take here?
20 degrees.
20 degrees you will take. What is the temperature of the oil here?
80 degrees.
80 to 50 it is there. So it is 80 to 50 means 80 plus 50 by 2. If you take, what is the value? It is like 130 by 2. 130 by 2 is 65. So for 65, you get the value here. Okay. Just interpolate and get that value. Will you interpolate or not? Or shall I directly tell? Try for interpolation, tell me. Please make it fast. చేస్తారా అది నేనే చేయనా
2068.
2068 you got, are you sure? 2047 is there here. Okay, 2068 can be the value. Cp is 2068 joule per kg Kelvin. Fine. So same value I'm substituting is here, 2068, and delta T on hot side is higher minus lower, 80 minus 50. Now I'm writing for the cold side, that is equal to m dot on cold side is given as this one, it is 0.08. 0.08 is given. Cp of water is known to you, it is 4180 into the delta T on this side is unknown. So what you should do is say here 20 degrees centigrade. If you look, what is the key words for this 20 degrees centigrade? See, with water available at. Water available at means whether it will be at inlet or an outlet. Tell me.
Inlet.
It will be at inlet. So this will be T1. Okay. Here you will take this T1 here or here. Which one is
Right,
correct? Huh?
right, sir.
See, ultimately what you have to do is you have to take a higher value minus lower value. So higher value you will get here or here.
I will get it left.
You will get it this one.
This one.
So what will be this? This will be T2. Okay, this will be T1. So T1 is known to you and its value is 20 given in question. Substitute and tell me what is the value of small t2. Quickly calculate and tell me what is the t2 value.
49.63.
49.63. Yeah? Okay, let us do one thing here. Let us take this 2068 as 2090 and solve it. Okay, this is for a reason. I'm telling this 2090. You will understand that reason shortly. Okay, intentionally I'm putting this 209. Huh?
50 degrees.
Yeah, it is a 50 degrees value now. Okay, T2 will be 50 degrees centigrade. Now, what is the next thing to do? You have to find out the LMTD. So, what is the formula for LMTD? This delta T1 minus delta T2 by ln delta T1 by delta T2. This is the formula, or you can write this formula from LMTD is equal to here here also this formula also you can use. Since this is counter flow, you can use this one here. It is T1 minus T2 minus T2 minus T1 by ln T1 minus T2 by T2 minus T1. Okay, this is the LMTD. So let us substitute the values here. In the capital T1, what is the value here? 80 kada? 80. In the small T2, you got it as what? 50. And capital T2 is what? 50 again. And what is small T1? It is 20 by ln 80 minus 50 by 50 minus 20. What is the value you are getting? LMTD. Please tell me.
It's 0,
It is 0. It is 30 here. It is
30
30
here.
here. So it will be 0 by something. So it will be 0. So LMTD is 0 here. Can this be the case?
No.
See here you have LMTD. If I draw the diagram here for the temperatures, oil is coming from 80 to 50 and water is going from 20 to 50.
Sir, it is not 0, sir. 0 by 0.
Delta T1 0 by 0 anyways. Delta T2. So here what's happening is delta T1 is equal to delta T2. This is a special case of LMTD. See, that is the reason why I have changed the CP value there to get this special case of LMTD. To teach you this, actually, I made the CP value something different. So this also you may get sometimes in the examination. Okay, so don't worry when you get this in examination. Okay, if that is the case, what you have to do? Okay, for that what you have to do is you have to take something called as AMTD. Okay, AMTD means arithmetic mean temperature difference. Okay, this is a special case. Sometimes you may get, sometimes you may not get. Anyways, then AMTD will be equal to delta T1 plus delta T2 by 2. This will be the thing. Delta T1 plus delta T2 by 2. So tell me what is the delta T1 here? 30. Delta T2 is also 30 by 2. That is again 30 degrees centigrade. You will get that. So the Q formula will be U into A into AMTD in this case. That is the only difference. Otherwise, you can put LMTD also here. Is that clear to you all now?
Yes, sir.
Fine. Now, okay. Do you know Q in this question? Q is nothing but MCP delta T. You know MCP delta T on both sides, so you can get it. So Q is equal to M into CP into delta T. Let us take it on the hot side itself. It is 80 minus 50 into the CP is 2090 we have taken. What is M actually? This should be written over here. Anyways, let me erase also. Here I'll write 80 minus 50. What is the M dot of oil given in question? 0.16 is given in question. So what is the Q value? Please speak out. Tell me what is this Q value. Calculate and tell me.
10032.
10032 watts. Good. So we are done with the left hand side, that is Q. What is on your right hand? You have AMTD. You are done with AMTD. Just now you have found out it is 30 degrees centigrade. Okay. What he is actually asking is, he is actually asking you to find the length. Length means it will be in area, that is pi dl. D value he has given in question. Okay. What is the D value given in question to you? Tell me.
2.5.
2.5 mm, 10 to the power of minus 3 you have to put. Okay.
Yes.
The L value is unknown. You have to get it. L value is the unknown.
Centimeter.
Centimeter, not this one. Okay, I will change that. Centimeter means it should be 10 to the power of minus 2 only. Right. L value has to be found out. You should know. Is U given in question? U ఇచ్చాడు question లో?
Yes, sir. 86.
U. Overall heat transfer coefficient, is that given in question? U is not given in question. Okay. U is not given in question. So you have to get the U value here. Okay. Yesterday I told you the concept of U. Okay. Do you remember how to get U?
1 by h water plus 1 by h
1
oil.
by U is equal to, the whole formula is there, and that formula is also available to you in page number 164 and 165. You can refer to that also. Okay. So 160, here it is. Let me rotate it. Here is a formula. Okay. Either you can use any one of them. Okay. So if you look at this, you will understand. Okay. So I will write the simplified view of this one. Okay. See, in question he has given that the resistance due to the tube is neglected, the tube wall resistance is negligible. So if that is the case, what I can do to this formula? In this formula I can take away the effect of this one. This is actually coming because of that tube wall. So this can be neglected and made 0. Okay, you have the remaining things here. Ri, Ro, Ri, Ro is there. So let me take this formula and write it here. So 1 by U is equal to 1 by Hi plus the fouling factor I have shown with F. He is showing with RF. Anything is okay. F on inside plus this factor I am neglecting, so I am not taking it here. After that, what I have here is another fouling factor. Another fouling factor is FO, and here he has taken the Ri by Ro plus Ri by Ro into 1 by H. O again. Is this okay for you? Simply, I have taken the formula that is there here and copied it here appropriately. Okay, sometimes he may not give you, it is negligible. Okay, then you have to consider these things also. Okay, so this is the thing here. Is HI given to you in the question? Speak out.
Yes, sir.
HI is given in question. What is its value? Please speak out, man. It is for water, I guess. Some 1,000 or something like that.
Yes, sir. It's 1,000.
It's 1,000. Okay, so it's given as 1,000 question, and the H on the outer side is also given, and the F is also given to you. 80 is given. This is given as 80. Okay, this one and this one are same actually. Okay, in the given question it is 00018 meter square Kelvin per watt. This is 80 watt per meter square Kelvin. Okay, so everything you have except this Ri by Ro. Except this Ri by Ro, you have everything. So what to do with this Ri by Ro? Tell me. Please speak out. Say, he said that the internal resistance is negligible. When will be the internal resistance is negligible? When Ri is almost equal to Ro, then resistance due to tube is neglected. So what happens to Ri by Ro? Will be almost equal to 1. Both are almost same. So this will be almost equal to 1. So this value is equal to 1 actually. So if you want U now, what will be U? U is equal to 1 by 1,000 plus 0.00018 plus 0.00018 plus 1 by 80. This is your U. Tell me what is this U?
Sir, is it 77?
72 I have with me.
Sir, okay.
72.1.
72.2 watt per meter square Kelvin. See, U can be given in question directly, or U can be found out indirectly like this. Okay. Most of the times they'll try to give you directly, but if it is given indirectly, know how to use these formulas here. Okay, these formulas are also available to you in the data book here. So either of the formulas you can take. Both are same actually. Both are not different. Okay, so you can use them appropriately. Right. So you are done with U. So now that you are done with U, in this one you can substitute U also, then get a unknown now. Q is equal to U into A into L. Sorry, it's not LMTD here, it is AMTD. Since special case we got in this particular problem. So A is equal to pi dl is equal to Q by A into LMTD. Sorry, U into LMTD. Sorry, A into U into. So tell me what is the Q value? చెప్తారా Q value ఎంతో 10032 by U ఎంత వచ్చింది 72.2. LMTD is 30. So you can get area now. Area చెప్పండి.
Sir, is L
Sir, L
59.
is unknown. 59 we get.
Hmm?
L value 59.
58.9.
Let's check.
59.9.
Pi into the D value is 2.5 into 10 to the power of minus 2. That is 59 point. చెప్పండి.
58.10.
0.
59.99.
58.9.
58 point. Okay. Meters is the L value. He is asking you to find in the question actually. Right? Is this clear to you? We are done. Okay. So with this, I will end the discussion on LMTD methods. Okay.